Hello, my name is Ed3.0 and today I want to present you an Excel file that is used to calculate the extension of explosion zones according to methodology of calculation presented in International Standard ESA 60079.10.1 classification of various explosive gas atmospheres. This Excel file is developed in order to simulate all scenarios defined in this standard and to give you an opportunity to calculate the extension of zones with all the necessary elements used in the calculation. As you see, data are only entered in the yellow fields. So let's start. We start with an example from this standard, and we'll go through a couple of examples in order to show you the way that this Excel file is working just to find standards. Examples, here they are. Example number 1. Here we have a situation where we are talking about benzene as flammable substance with its molar mass, low flammable limit, 1.2%, auto ignition temperature, etc., gas density. Source of the release is rupture on the mechanical seal. It is secondary source, leakage due to the seal rupture, and we have a release rate of 0.192 kilograms per second that is going through a hole size of 5 square millimeters under pressure of 15 bars. After the release of liquid, we have evaporation of liquid with estimate of 2% of mass will evaporate. Volumetric release characteristic is 0.099 cubic meters per second. We have outdoor situation on unobstructed area, a normal ambient pressure, temperature of 20 Celsius, wind velocity of 0.3 meters per second, and availability of ventilation good. This example is not intended to represent the method, but to represent the way that in this situation method is applied. So we're back in the Excel calculation. We have one source of gas. Name of the source, it's some kind of normal industrial pump. You can enter what your situation is. Name of the company, location, and description of situation, it's mechanical seal rupture. Characteristics of situations are in the first green box. So we have gas, benzene, type of source, secondary. You can choose either primary or continuously, but in this example we use secondary. Primary source is kind of source that is expected to have a release of gases during the normal operations, like safety valves or something else, and continuous, like the sources of liquids, etc. In this case, we have diffuse gas. We can have heavy gas if it is much. If it is heavier than air, it will go down, and we have a situation with jet releases when the gas is emitted through the some small nozzles with big speed. In this case, first we have release rate of liquid, and these are the external situations. We have natural ventilation, availability good, it is open space, you can choose closed space, open space, you can choose medium, bad and good availability, and the type of ventilation, natural, forced, etc. Number of sources 1. After entering all the data in this green box, we can go to the second box where we define gases. In this Excel program, we have a sheet with the data of predefined gas that are most commonly used in industry, that are explosive and that can lead to forming of atmosphere with explosive gases. You have molar masses, low flammability limit, upper flammability limit gas group, is it C, A or B, polyotropic index of adiabatic expansion, boiling point, auto ignition temperature, flash point. I will not go through details about these characteristics, you can read them in standard. So let's back. You have option to select mixture of gases. Gas number 1 can be benzene, gas with the concentration of 100%. We can lower it, say it's 60, and choose another gas, let's say propane, with concentration of 40, and the program will calculate. You can add other gases, but this maximum number is 7, and the program will calculate molar mass of mixture, low flammability level of mixture, polyotropic index of adiabatic expansion, a vapor pressure of the mixture. In this example we use only one gas, and it is benzene with concentration of 100, and we exclude this gas. Let's go further. Source characteristics. In this case, we selected in the first box release rate of liquids. You can choose release rate of gas or vapor according to Annex B, Article 7.2.3. You can choose release rate of gas or vapor evaporation that are used when evaporation is occurring. Known volumetric release and known amount of gas emission, square meters per hour or kilograms per hour. In this case we use release rate of liquid because in this example it is said that the liquid is pouring through the hole of 5 millimeters squared. That is an area. So let's back, and we skip this option and go to the release rates of liquid. Here you see we have an opening of 5 millimeters squared. We have a pressure, it is entered 16 because you have to, the pressure difference is 15. The pressure outside is 1, so if the pressure difference is 15, then inside must be 16. Percentage of liquid that evaporates after spillage, 2%. We have discharge coefficient, and the density of liquid inside the vessel is calculated, and you can see here, I will put bigger font. We have calculated that the release rate of liquid is 0.19221, and the standard says it is 0.192. I suppose the this is pretty good accuracy. Here we are again at our example. As we said, the release rate is 2% of the spilled liquid, and in example it says 3.85 kilograms per second. We have calculated that is 0.003844. It is not 3845. I will change font so you can see it clearly. Kilograms per second, and the standard says volumetric release characteristic, that is data on the x-axis of the plot, is 0.099. In this calculation we established that is 0.0987. It is pretty close, and now we can go further on this to work on scenarios of the ventilation. In this third column we discuss the ventilation details. As we said, it is natural ventilation with good availability. We are not going to change this box because this is artificial forced ventilation, and because this is open space, we are going to skip all this box and come back to it later when we discuss closed scenarios in the closed space. So we have open space with the wind speed. You see here we open space, wind speed 0.3 meters per second, and here you can see selected air velocity above the source is 0.3, because this Excel program takes your decision from this first box. So when you check here it is open space, it will automatically take the velocity that you entered here for the open space. You can see this here calculation for the background concentration, and we can see time to reach X critical is 8 minutes. That is not so bad. Now we have the plots that are used to determine the extension of explosion zones. Release rate characteristics, as we said, is here just about below 0.01. It's 0.099, and we have here the situation with the ventilation velocity. We said it's 0.3, so it gives us dilatation, medium dilatation, with the characteristic of release. We said it is diffuse. So again, according to release characteristics, and in the when we have the cross section with the medium line, we have distance of 1.35 meters, and we adopt 1.5. So it is zone 2 because we have scenario with the secondary source, good availability, and degrees of dilatation medium. We have situation where we chose the diffuse gas and obtained 1.5. We rounded to 0.5, and we got 1.35 rounded to 0.5, it's 1.5. If we change initial settings and says this is heavy gas because it is 2.7 times heavier than air, then we have a situation when safety distance is calculated to 2.78 and adopted 3 meters rounded of 0.5. You can see here it is the same as in example. Just a second to find the example again. Here it is. You can see it stretches over 3 meters as we calculated. Yes, I forgot. I want to show you the language options in this file. As you can see, we can Serbian, English, Polish, German, French and Arabic options. You can select that by taking back to its start menu, and as you can see you have language options. Let's say we want German, and all the text in the Excel file is automatically transferred into German language. We have some job to do to manually change some fields because they are left from the previous option, and that's it. You changed the language. Now when we generate Word file, it will be on German language. I will back now this to English and again change the settings in order to natural good ventilation, because I'm not good with English, any other language except English and Serbian. Okay, now as you can see, the Excel can be used in those languages. If you want me to implement your language, it's no problem. I have the language file, so I can easily put your language as an option. So that's it. I will not save. And now I want to show you the example number 4 from the standard, because it is very nice example of release rate through the ruptured seal. And let's begin. We have propane based gas mixture with molar mass, lower flammability limit, auto emission temperature, gas density, and we will calculate the release rate. We have outdoor situation with the ambient pressure, temperature and ventilation velocity above the source with good availability. Again, you have the name of the source, location where the source is located, pump station in this example, and packing rupture, or the description of situation when the emission is created. We have propane, yes, it's propane based. We have secondary, and we have diffuse gas. Scenario is number 1, release rate of gas or vapor. You can select different scenarios, but this is the scenario described in this example. Ambient temperature, normal atmospheric pressure, natural ventilation because it is open space, let's say open space, and availability is good. Number of sources 1. Gas, we have propane with concentration of 100%. We can select some other gas, but in this example it is propane. You can modify these data in gas table sheet, and you can adjust them to be as you wish. You see here is the data from the standard. We have 1.7% volumetric concentration for low flammability limit, but in the standard 60079-20 it is 2.1. I changed it to be in accordance with this example. Let's go further. As I mentioned earlier, you can add other gases, and the Excel file will calculate gas mixture, total parameters, low explosion limit, upper explosion limit, and total molar mass of mixture. But in this case we have only one gas. Sources, characteristics of source release. We selected number 1. We have hole with a diameter of 2.5. Let's check it. Yes, source 2.5. We have temperature of 15 degrees and a pressure of 10 bars. 10 bar pressure, 15 degrees. Compressibility factor for propane is 0. You can read the notes later. And we calculated that the release rate is 0.00508, and in standard we have 506 times 10 to the power of minus 3. It's pretty close. And after that we have this release characteristics with 0.1633. Because we have situation with the open space, we select speed for open space, and air velocity above the source will be the speed of wind in the outdoor situation. And now we can see the graphics. We have situation with medium dilatation, and the heavy gas we calculated, it is safety distance 1.73, adopted 2 meters, rounded because it is rounded to 0.5 meters. In standard they calculated, you see release characteristic is 1.62. in standard also they have diluted medium situation and 2 meters because it is diffusive. If we select jet release, it will be smaller. Jet release. Okay, now let's see our graph. Okay, yes, it's smaller, it's 0.84. We adopted 1 and rounded 0.5. This is nearly over. All we have to do now is export to Word document, generating Word file with report. Okay, now we wait. Excel will generate files. Currently you are seeing the flickering of the screen. In the macro I can turn that off. The new Word file is generated. Okay, and let's see the file. Here it is with all the data and formulas used to calculate you see the name of the source, ABS company plus address, pump station, packing rupture, gas propane with all its characteristics, gas mixture. We have jet release characteristic, scenarios, release rate of gas of vapor, and etc, etc, all the way down to the graphs. If you want graph with the diffuse gas, you change this to diffuse and generate word report again, but you rename this file in order to save it. In order to save it, you can rename it. Let's say report 1 and make another one with this time diffuse gas. One other thing. Now I want to discuss the option of calculation done in the closed space with natural ventilation. Of course, calculation can be done in closed space also with artificial ventilation. Now we have example 4 and from the standard, and I will modify it. Okay, it's propane gas, secondary source of release, diffuse gas, no problem. Release rate of gas or vapor, we talked about it, that is option 1 scenario, and now I'm going to change it and say it is closed space. Because it is closed space, I will say ventilation is natural and it is with good availability. Let's jump to the section with the ventilation. We discussed this characteristics of release rate, and we have pretty accurate release rate according to the standard. Now let's talk about ventilation. Because we said it's natural in closed space with good availability, now we are going to define the dimensions of the openings on the walls. Dimension of the opening 1-1 and -1-2, these openings are coupled and they are on the same dimensions with different heights. Dimensions of this opening is 0.5 and let's say 0.25. Height is 4 meters, and the other one is the same, let's say, or it does not have to be same. This one is a little bit bigger, and the height is 0.5 meters from the ground. Now we have two openings. The software will calculate. Local ventilation does not exist, okay, and we say artificial ventilation does not exist, it is 0. Only one that is left is ventilation through those openings with the elements that come into this calculations are wind speed outside, temperature, exterior and interior temperature. Interior temperature, let's say, can be higher, 30 degrees, if the outside temperature is 24. Now we have a ventilation of 635 cubic meters per hour. This is ventilation due to the natural conditions and the two openings that we have. This Excel file allows you to have more openings if you want. Let's say opening with dimensions 105 at the height of 4 meters again, and smaller, 1.5, 0.2 at the height of 0.4 meters. Now we have a higher ventilation because now we are talking about 2 pairs of openings, but 1 will be enough. I will clear it. Okay. Okay, and this height also shall be cleared. Let's go further. The area where gas is located. Now we have closed space. Okay, indoor dimensions 5 meters, width, length B 5 meters, and height is 5 meters. Space volume 150 cubic meters. Percentage of effective volume. If there are some equipment or some obstructions inside the closed space, then you will put percentage of those obstructions. In this case we have 10% of objects obstructing the volume, so the free volume is 135 cubic meters. Directions between walls of width L and height. So we have 2 pairs of openings. They are on the opposite walls, where between wall length L and length and height A, or wall width B and height H. Let's say this is the position of our openings. So we have calculated that the air speed in a closed space above the source is 0.0059 meters per second. This is due to the natural ventilation. And with this number we go into our graphs. Let's see how it looks like on graphs. Also we have here calculated the background concentration. It is almost just a little bit of 3 hours. So we have low dilatation. It is not good ventilation. The openings are small, and because of that, zone 1 or even a zone 0. Let's put some larger ventilation openings. 0.5 and here 0.5. Let's see how this affects our dilatation. Oh, we have zone 2. We are slightly above the limit, and we can say now it's dilatation medium. When we compare release characteristics with those 3 limits for diffusion, heavy gas and jet release, we have a safety distance of 1.73, or we can adapt to 2 meters. Now if we, from the source, now if we select jet release, we'll have a smaller zone and it will be 0.84. I just wanted to represent you the options for the ventilation in closed space with this modified example number 4. And at the end, if you liked this Excel file and capabilities that it has, it can be yours, and this purchase can be made over the bank transfer. I will send you pro forma invoice for your company and you can pay via bank transfer. If you don't have that options, the other option is, of course, the best way, Bitcoin. So feel free to ask me anything you need. This is my email address. I am sure I can help you. This Excel file covers every possible scenario represented in the standard, and when you purchase this Excel file, you will have all 5 examples from the standards in detail and in reports according to the scenarios they cover. Thank you again, and feel free to ask me what are your needs. Thank you.